Ever feel like time is slipping away? Well, get this. It literally is.
Yeah.
Welcome to our deep dive on time travel,
Time travel.
where we'll uncover how this sci-fi staple is actually rooted in, get this, reality.
It's not about phone booths
Yeah.
or DeLoreans.
Right. It's about the mind-bending science of time dilation.
Yeah, time dilator.
Okay, you got to break that down for me.
So imagine time as a river constantly flowing. But here's the twist. The riverbed isn't always flat, right? It can bend and warp,
Okay.
making the water flow faster
Right.
or slower in different areas.
Yeah.
That's kind of what happens with time,
Good time.
thanks to Einstein's theory of relativity.
So time isn't this constant steady thing we perceive it to be?
Exactly. It's relative,
Relative.
meaning it can be influenced by factors like speed and gravity.
Speed and gravity.
Our sources today delve into both.
All right, let's start with speed. I'm ready to put the pedal to the metal on this time travel thing.
Then hold on tight. The faster you move through space,
Oh, okay.
the slower time moves for you
For me.
relative to someone standing still.
Wait, really? So every time I'm driving, I'm technically a time traveler?
In a way, yes.
What?
But we're talking incredibly small fractions of a second at everyday speeds.
Oh, okay.
To see noticeable time dilation, we need to look at much higher speeds,
Okay.
like those achieved by astronauts.
Astronauts like those on the International Space Station.
Precisely. They're orbiting Earth at thousands of miles per hour.
Yeah.
Astronaut Scott Kelly
Scott Kelly.
spent almost a year on the ISS.
Wow.
When he returned, he was a smidgen,
Yeah.
younger than his identical twin who stayed on Earth.
That's incredible. Proof that speed can actually affect the way time passes for us. It makes you wonder what would happen at even more extreme speeds, like approaching the speed of light. Now that's got to mess with time in a big way, right?
Absolutely. As we get closer to the speed of light, things get really strange. Imagine this. You're on a spaceship,
Okay.
traveling at 99% the speed of light.
Mm.
You take a short trip, maybe a few weeks for you, but when you return to Earth, decades, even centuries could have passed.
Wow, so a one-way ticket to the future then.
Essentially. Of course, we're not quite at a point where we can build spaceships that travel at those speeds.
All right.
But we do have real-world evidence of time dilation happening on a smaller scale,
Smaller scale.
even at speeds far slower than light.
Okay, I'm all ears.
Think of particle accelerators.
Yeah. Particle accelerators, okay.
These incredible machines propel tiny particles to nearly the speed of light.
Nearly the speed of light.
Scientists have measured that these particles actually exist
Okay.
for a longer period than they should,
Interesting.
purely because they're traveling so fast.
It's like time slows down for them
Yeah.
to compensate for their incredible speed. It's like those particles are getting a tiny taste of the future, but hold on. If speed can distort time, what about gravity? Our sources say that plays a role too.
It certainly does. To understand this, let's shift gears and imagine a giant trampoline.
I'm intrigued, but a trampoline, where are we going with them?
Okay, so think of gravity like a bowling ball.
Okay.
Placed on that trampoline, it creates a dip, a curvature in the fabric, right?
Okay, I see where you're going with this. Gravity warps things, just like that bowling ball.
Exactly.
Yeah.
Now imagine the trampoline represents something called space-time.
System. Okay.
It's the fabric of our universe, where space and time are interwoven.
Right.
Massive objects like planets and stars
Yeah.
create a sort of gravitational dip
Mm-hmm.
in space-time,
Mm-hmm.
similar to the bowling ball and the trampoline.
So gravity actually warps the fabric of time itself. It's not just about things falling to the ground.
You've got it. The stronger the gravity,
Okay.
the more pronounced the warp in space-time,
Mm-hmm.
and the slower time flows
Right.
relative to areas with weaker gravity.
This is blowing my mind. So if gravity is stronger at sea level, does that mean time moves a tiny bit slower for me down here compared to someone on top of Mount Everest?
You're on the right track.
Great.
We're talking incredibly precise measurements here, but
Okay.
experiments with atomic clocks have actually proven this.
Really?
Those clocks at sea level, closer to the Earth's gravitational pull,
Yeah.
tick ever so slightly slower
Wow.
than identical clocks placed at higher altitudes.
Wow. I had no idea. Something as simple as climbing a mountain could make me a time traveler, even if it's just by a fraction of a second.
Mhm.
But let's talk about the ultimate example of gravity's influence on time. Black holes.
Oh, yeah.
They're like the cosmic vacuum cleaner sucking everything in, even light. What's happening to time near one of those?
Black holes are fascinating, aren't they?
Yeah,
They possess an immense amount of gravity
right.
concentrated into an incredibly small space.
Yeah.
This creates a gravitational well so deep, it's almost as if they punch a hole in the fabric of space-time.
So if I were to get too close to a black hole and survive, hypothetically speaking, would I experience time differently?
Let's just say time would behave very strangely near a black hole.
Okay.
For someone approaching the event horizon, the point of no return,
Right.
time would appear to slow to a crawl relative to an observer farther away.
Oh, wow.
And at the singularity, the heart of the black hole, our understanding of physics breaks down.
Wow.
Some theories even suggest time might stop altogether.
So black holes are like the ultimate time machines. It's like stepping into a cosmic freezer.
It's a captivating thought, isn't it?
Yeah.
And it highlights just how different our perception of time is
Right.
from its true nature. We often think of time as this rigid, unwavering constant.
Yeah.
But in reality, it's much more fluid.
Influenced by the very fabric of the universe itself.
Okay, so we've covered how speed and gravity can warp time. It's all pretty mind-blowing, to be honest. But what I find most fascinating is that this isn't just theoretical physics confined to labs and textbooks. This stuff has real-world implications.
Absolutely. The technology we use every day relies on our understanding of time dilation.
Really? Give me an example. I never would have guessed that time travel plays a role in our daily lives.
Think about GPS,
GPS, okay.
the global positioning system.
Yep.
It's how we navigate,
Right.
track our deliveries,
Yeah.
even find that new restaurant across town. But it wouldn't be possible without accounting for the effects of time dilation.
Wait, what does GPS have to do with time dilation? I'm dying to know.
It all comes down to those satellites orbiting our planet.
They're positioned high above Earth in areas where gravity is weaker
Okay.
compared to us down here on the surface.
Okay, so weaker gravity means time runs a bit faster for those satellites. Are we starting to see a pattern here?
Exactly. But there's another factor at play here. Speed.
Right.
Those satellites are zipping around Earth at thousands of miles per hour,
Yeah.
which, according to relativity, should cause their clocks to run slightly slower compared to clocks on the ground.
So we've got two opposing forces here. Weaker gravity speeding up time and high speed slowing it down. Which one wins?
That's the incredible part.
Okay.
Engineers have to account for both effects
Right.
to make GPS work accurately. And it turns out the weaker gravity actually has a slightly stronger influence in this case.
Oh, interesting.
So the clocks on GPS satellites actually run a tiny bit faster than clocks here on Earth.
Mind have officially blown. So you're telling me my phone is constantly making tiny time travel calculations just to make sure I don't miss my train?
Yeah.
That's wild.
It's a testament to how elegantly these principles of physics are woven into our everyday lives, often without us even realizing it.
It's amazing how something we take for granted, like GPS, relies on such mind-bending physics.
Yeah, it really highlights how deeply intertwined these principles are with our understanding of the universe. And who knows?
Yeah.
What other technological marvels await us as we continue to unravel the mysteries of time?
Our sources even touch upon the idea that maybe, just maybe, we could one day harness time dilation for interstellar travel. Imagine strapping into a spaceship, blasting off to a distant star system. And because you're traveling at a significant fraction of the speed of light, you experience time much slower than those back on Earth.
It's a tantalizing concept, isn't it? To return from such a journey having aged only a few years while decades, even centuries have passed back home, it would be the ultimate testament to humanity's quest to conquer time itself.
It sounds like something straight out of science fiction, but as we've learned today, the science behind time dilation is very real.
Indeed. And while the technology to achieve such incredible speeds is still far beyond our current capabilities, who knows what the future holds? A century ago, the idea of humans walking on the moon seemed like pure fantasy. Yet, here we are.
That's a great point. It makes you wonder what other seemingly impossible feats we might accomplish in the centuries to come. So, if we could dream big for a moment, what would be the ultimate achievement in our understanding and manipulation of time?
That's a profound question. Perhaps it's not about conquering time, but about unlocking its full potential. Imagine a future where we can not only navigate the cosmos by manipulating time dilation, but also use our knowledge to address challenges here on Earth. from preserving our planet to understanding the very nature of consciousness.
It's both awe-inspiring and humbling to think about the possibilities that lie ahead, all stemming from this fundamental concept of time dilation. It makes you realize that we're not just passive observers in this grand cosmic dance, but active participants in the very fabric of time itself.
And that, I believe, is the most exhilarating takeaway from our deep dive today. Time is not just something that happens to us. It's a fundamental aspect of the universe that we are beginning to understand and even influence in ways we never thought possible.
So, the next time you glance at the clock, remember that it's not just telling you the time. It's a tiny window into a universe far stranger and more wondrous than we could have ever imagined. Thanks for joining us on this journey through the fascinating world of time travel and time dilation. Until next time, keep exploring and keep those minds wide open.